Hello. Today I'll show you how to draw CRC shift registers based on given generator polynomial. And there's a fact that you have to know first, that when you divide the message by the generator polynomial, you will get a quotient and you will get a remainder. In the realm of CRC, we are not going to care too much about the quotient, and instead we're going to worry about the remainder. And this is essentially what CRC shift register calculates. And there's a fact about the remainder that you have to know, is that the highest degree of the remainder, it's always going to be less than or equal to the highest degree of the generator polynomial minus 1. And let me show you really quick. So if you have a message x to the 7th plus some arbitrary polynomials, and if your generator polynomial is x to the 3rd plus some arbitrary polynomials, you will first calculate your quotient, and your remainder is going to be x. And so the highest degree is going to be 1. And let's say if you have a x to the 8th plus some arbitrary polynomials divided by x to the 3rd, and you're going to have x to the 2nd, and you will have x to the 6th, and the highest degree will be 2. And lastly, so if you have x to the 9th plus arbitrary polynomials divided by x to the 3rd, you will have 0 or 0 times x to 0 as your remainder. So the highest degree is going to be is going to be 0. So once we know about this fact, we can then calculate or draw the CRC shift registers. So we know that if our highest degree is 3, then we know that there's going to be 3 digits remainder left. Why 3 digits? You will have 0 x to the 3rd plus something x to the 2nd plus something to the x and plus a constant or something x to 0. So this is what the shift register is going to compute, is x to the 2nd, x to the 1, and x to the 0. And since we're not going to have a x to the 3rd, we'll ignore that register. So the first rule of drawing CRC shift register is first knowing the highest degree of your generator polynomial. In this case, we have a 3, so that means we draw 3 boxes at the beginning, because we'll have 3 digits as our remainder. And second, you always have to know that message comes in from the left. And so message is constantly fed into these registers, and registers, the remainder of the registers will be your remainder. And this will be our x0, and this will be our x1, and this will be our x2. Again, we don't have an x to the 3rd, so we don't have a register for that. Now let's move this apart a bit. Pardon me. Let me draw this again. We have x to the 1st and x to the 2nd. Now, we have, let me rewrite this this polynomial again. So we have x to the 3rd, and we're not going to care too much about that, plus 1 x2 plus 0 x to the 1 plus 1. And now if you look at this, if you see a 1 before a polynomial, then that means you need to put a XOR gate in front of the register. And XOR gate is drawn like this. So let me rewrite this a little bit. So we see a 1 in front of x to 0 and 1 in front of x squared. And we have to put a OR gate in front of x to 0 and an OR gate in front of x squared. And now the message, again, comes from the top and is fed into to the right. Now, at the end, the message is going to be fed back into all the OR gates. And there you go. That's your CRC shift registers. And let me do another example real quick. So suppose we have a generator polynomial cx equal to x to the 7th plus x to the 6th plus x to the 4th plus x. And we have to first find out the highest degree polynomial. So the highest degree polynomial is 7. That means we have to draw 7 boxes. Now that's the first step. Second step, we have to rewrite this polynomial to a better format that we can understand. So it's 1x to 7, 1x to 6, plus 1x to the, it's 0x to the 5th, plus 1x to the 4th, plus 0x to the 3rd, plus 0x to the 2nd, plus 1x, and plus 0. Okay, and now let's label our registers: x to 0, x to the 1, x to 2, x to 3, 4, x to the 5th, and x to the 6th. Again, we do not have a register for x to the 7th because we'll never get a remainder that has a polynomial with highest degree of 7. Again, our message always comes from the left. And now let's find all the ones in front of our polynomials and put an OR gate in front of the registers. So we ignore the x to the 7th, and we put 1 for x to the 6th, and we put 1 for x to the 4th, and put 1 for x to the 1st. Now, message always go from left to right. So let's draw our arrows. Now, when the message reached the end, everything is going to be fed back to the OR gates. And that is how you draw a CRC shift registers. Thank you very much for watching.